Well, good morning. It's Monday the 11th of May and we're doing our Corbett Maths Foundation 5 a day, which we do every week, and we're looking at the 6th of May today. So we've been moving through our booklet if you're working through the booklets. Otherwise you can download this and have a go at it, and if you haven't had a go at this, I would definitely pause the video now and have a go at this. I'll put a link to the Corbett Maths in the video description. So our first question is, 3 paintings cost £186. How much would 5 paintings? And we're taking it that it's the same painting that we're buying. So the first thing we need to do is to find out how much one painting costs. So we're dividing the 186 into 3 equal pieces. 3 doesn't go into 1. So we carry that. So 3 goes into 18 6 times and 3 goes into 6 twice. So we now know that each painting costs £62. We've got to find out the cost of 5 paintings. So I'm just going to very sneakily do 10 paintings, and 10 paintings would be 620, which means 5 paintings will be £310. So just a very sneaky way of multiplying by 5 there. I didn't even multiply by 5, I multiplied by 10, and then I halved my answer. Of course, you could do 5 6s are 30 and 5 2s are 10, and a power of 10 in there, giving you the 310. The second question, very sneaky question and a calculator question. We're asked to find the area of the parallelogram. If I collect and cut out that triangle and connect it in there, you see that we actually get a rectangle, and the area of a parallelogram is its base, its length here, or its length here, multiplied by its perpendicular height. And this is exactly why, because you cut out the triangle there, you stick it there, you can actually create a rectangle. So the area is the base, 11.2, multiplied by its height, 5.2. If you guys have actually done that without a calculator, I'm very impressed. You'll maybe used a Chinese multiplication or some grid multiplication there, but I am going to perform this on the calculator, and I've got an answer of 58.24 centimeters squared. So that's the only question I would say on this sheet uses the calculator. The rest of the questions I do believe are non-calculator. So let's move up to the next question, and this is a BIDMAS question. So we've got brackets, indices, divide, multiply, add and subtract. Well, we haven't got any brackets, but we have got an indice here, so we write 100 minus 25 times 2. So I've squared my 5 there, 5 times 5 to generate the 25. So that's my indice done. I've not got any division, but I have got a multiplication here, and 2 25s generate 50. And then a straightforward 100 minus a 50, giving me a final answer. Now, as I've shown a number of times on the calculator is programmed to work with BIDMAS, and there you can see I've just typed that in. So we're very lucky that our calculators do work with BIDMAS. That wasn't the case back in the late 80s, early 90s when I was at school. So find the nth term of the following sequence. So what we look for is our first difference here, first difference here, and first difference here. And what we're doing is we're checking that that's a constant, so that it's a linear sequence. To get from there to there, you add 4. And to get from there to there, you add 4. And to get from there to there, you add 4. Now, when you were at primary school, you were all taught a sequence that went up by a positive 4, and that was the 4 times table. So we now know that the answer is something to do with 4n, the 4 times table. The 5 times table, we write 5n, the 8 times table, we write 8n, and the minus 2 times table, we write minus 2n. But this is the 4 times table, so we write 4n. Now, the 4 times table, the official 4 times table, looks like that. So we're supposed to have 4 in the first position. We've got 9. We're supposed to have 8 in the second position. We've got 13. We're supposed to have 12 in the third position. We've got 17. We're supposed to have 4 in the fourth position, and we've got 21. So we're obviously modifying the 4 times table. And how are we modifying this? Well, you can see we're adding 5 to generate 9. We're adding 5 to generate 13. We're adding 5, quite straightforward, easy, you want to see that, to generate the 17. And we're adding 5 to generate the 21. So we are indeed add in 5. It's 4n plus 5. Now some of you will know how to find that by stepping this sequence back by doing the opposite. So down by 4, down by 4, down by 4 and down by 4 gives you that positive 5 there for the constant in that. So if you know that method, that's superb and well done, and that will get you the answer as well. We're now looking for the 50th term of this sequence. So n equals 50. I should have wrote that first of all, sorry. So it's 50 into where n is, and BIDMAS of course tells us to multiply before we add. So 4 50s are 200, and then we add on 5 and we get 205. Again, a nice little check on the calculator here. We can actually type in that sequence there. So 4n plus 5. That's how I type it in on the calculator there. So 4n plus 5, and we put in there the 50th term. So that's the n value, and again it's generating that 205. So a lovely little check on the calculator there as well. And our final question today was a geometry reasoning question. It says, is the line CD and EF parallel to one another? Are they parallel lines? Can we draw arrows like that? Well, of course we can just draw the arrows on, but can we mathematically prove? Well, there is a little known fact in maths, particularly on the higher part of the foundation paper, that grade 5 area, and only grade 5 students I feel know this, and it is that co-interior angles add up to 180 degrees, and co-interior are quite literally what we've got here, going across and back up. So if these two add up to 180, then these two lines CD and FE are parallel, and if you add those two together you get 10 to carry, and then you get 10 there, plus you do get the 180 degrees. So these two lines are parallel because we've got co-interior angles, and co-interior angles add up to 180. A really important fact to try and remember within your parallels. Most people know alternate angles, another bunch of people know the corresponding angles, but this one I always find is a grade 5 standard. If you know your co-interior angles, and lo and behold, they do make a very nice C shape as well. You can't mention the C shape in your exam, you've got to reference your co-interior. Well, that's everything from me today. We're just going to have a little look ahead to May the 7th in the booklet. Like I say, some of you will be working for this booklet, otherwise you can find these questions on the internet. So next Monday we will be looking through we'll be looking through the 7th of May. So we're looking at similar shapes. We've got a speed question, we've got some volume there, we're doing some conversions between meters and centimeters, and then we're doing some increasing by percentage as well. As I say, all these sheets can be found on the internet, www.corbettmaths.com. So if you want to get ahead of the game and have a go at what we're going to be looking at on next Monday's video, we will be looking at the 7th of May. Stay safe everybody, I hope you're all very well, and I will see you in a week's time. Thanks for watching.